In lesson 4-8, we're going to talk about dilations. When talking about dilations, I always tend to think about my eye and my pupils. When you go to an eye doctor, sometimes they put a drop in your eye that dilates your pupil, which in that case makes your pupil larger, so that way when they look into your eye, they can see more things. Just like if you're in a dark room on a summer day and then all of a sudden you walk outside, you feel your eyes, you have to squint because your pupils, when you're in that dark room, your pupils are dilated larger, and then when you step outside, all that light is rushing into your sensors, and so your pupils have to quickly shut. And so before your pupils can shut, it hurts your eyes, so that's why you have to squint your eyes, and then your pupils dilate down so that there's very small holes for the light to get through, and so then you can actually see clearly after your eyes get a chance to actually adjust to the light and things like that. So your eyes are a neat tool, and so whenever I think of dilations, I think of my eyes and my pupils either getting larger when it's dark or getting smaller when it's light to let in either more or less light. So dilating is a shape either getting larger or smaller, and it is important to know what is the center point of how it's getting larger or smaller. If you think of your eye, it's going off of the center of your eye, so it's either getting larger, the pupil is getting larger, or it can be shrinking and getting smaller all the way down to that center point. So it's just a matter of what is the center. Sometimes when we're talking about graphing, the center could be the origin, or the center could be one of the points of the shape. And so if we were going to get bigger based on the center won't move, but it may get bigger like this if that is the center. If the origin is the center, that would change some things too. So it's important to know what the center is. For an enlargement, your scale factor, so I'm abbreviating scale factor, your scale factor is going to be greater than 1. And for reduction, your scale factor is going to be less than 1. So obviously, if you multiply by 1/2, it's going to get smaller by a half. And if you multiply by 2 or 3, obviously the shape is going to get larger by either doubling or tripling. And then, of course, you can get larger by like a fraction. So if I enlarge it by 3/2, well, 3/2 is like 1.5, which is greater than 1. So that would be an enlargement as well. So looking at my first example here, it says copy polygon PQRS on graph paper, then draw the image of the figure after a dilation with the center S by a scale factor of 1/2. So we're using the center S, so this is where we're going to start. We're not going to actually move S because it is our center point. Now it told us that we're going to dilate it, so we need to know that this is going to shrink or get bigger. So sometimes I like to grab this shape here. This would be like dilating down, we're shrinking it, and this would be the opposite of that, we're actually enlarging it here. So just kind of an example, obviously we're moving the point S around, which we wouldn't want to do. Right now when I'm moving it, the center point is actually this corner of my image right there. So that's just kind of an example, a quick example also of dilating based on a center point. In that case, it was right there. Now, when we look at the scale factor is 1/2, so that should tell us that we are having a reduction in our shape. So we know that our shape is going to get reduced. It's going to get smaller by half. So this side length is 1, 2, 3, 4. So right now it's 4. Our new shape is going to be only 2. And then when we label it, we're going to label it P prime. P is the original P. Whenever you have a prime, you know that that's the changed version or the dilated version. So S will also be S and S prime. We're actually not going to move that one. So again, here with this one, we know that it was 1, 2 distances. 2 spaces away, so we're just going to shrink that down to just 1 space away. And we knew it was straight across, so we're going to also make it straight across. And we're going to label that Q prime. And for this one, we know that R is straight across from S. We're going to go 1, 2, 3, 4, 5, 6. So right now it's 6 units away. We're going to shrink that down to 1, 2, 3. And we're going to make R prime right there. And then we can draw our new shape, our new dilated shape in. And so this trapezoid, PQRS, that's the original, and then we have P prime, Q prime, R prime, S prime is the dilated reduction of 1/2 using the scale factor 1/2. So notice the S point did not move because that was our center. The center doesn't move. So if you ever have a point that is your center, the center won't move. Sometimes we'll have the origin as the center. So for example 2, it says graph triangle MNO with vertices M3, -1. So let's go ahead and put that point in. So we'll go 1, 2, 3, -1, and we'll always label that M. This is our original, so we're not putting a prime. N is 2, 1, 2, -1, 2. So there is point N. And O is 0, 4. So we're going to stay at the origin, go up 1, 2, 3, 4. So our point is right there, and that is point O. So now we'll want to connect those lines. I'll use my line tool so they can be nice and straight. It's important to make our points or our lines nice and straight so when it's easier to see everything. Now it says, then graph its image M prime, N prime, O prime after a dilation with a scale factor of 3/2. So it didn't give us a center point, so we're going to use the origin as a center point, which actually works really nicely with our ordered pairs because we'll just be able to work with those ordered pair numbers. And then we have a scale factor of 3/2. Well, that's greater than 1, so we know that our triangle is actually going to get larger. So first of all, when we think about M prime, well, I'm using the points 3 and -1, so I'm going to take 3 times 3/2. Well, when I take 3 times 3/2, what I get is 3 times 3 is 9, and 9 divided by 2. 9 divided by 2 is 4.5, so I'm going to write 4 1/2. And I am going to write it as a mixed number here just so it's easier for me to graph it later. And then I'm also going to take the -1. -1 times 3/2. Well, I know that that's going to be a -3/2, and 3/2 would be 1.5. So -1 1/2 is going to be my M prime. So then I can go to my N prime. Again, it's talking about a factor, and we know that factors are used when we multiply, so that kind of tells us what to do there. Now, point N is going to be a little easier for us because we have 2 times 3/2, and the 2's are just going to cancel, so I'm just going to be left with the 3. So I get 3, comma, and then I'm going to have -2 times 3/2. So the 2's will cancel, but I'm going to be left with this negative, so I'm going to have 3, -3. And then lastly, I'm going to have O prime. And here, 0 times 3/2 is obviously going to still say 0. But then I'm going to take 4 times 3/2. And the 4 and 2 will simplify to be just 2 over here and 1 down here. And 2 times 3 is 6. So I'm going to get 0.06. Now I can go ahead and graph. So M prime is 4.5. So 1, 2, 3, 4 1/2, and then I'm going to go down 1 1/2. So my point M prime is right there. So see, it hasn't moved very far because if you think about it, we're just using a scale factor of 3/2. And then N prime is going to be 3, -3. So 1, 2, 3, 1, 2, -3. So again, it hasn't moved too terribly far, but we're going to go with the M prime there. And then O prime is 0.6, so 1, 2, 3, 4, 5, 6, all the way at the top. The 0 obviously doesn't change because we can't change a 0 with by multiplying by a factor. So 0 prime is there. And then I can graph my new dilated image by going ahead and marking these with my line tool. And now I am finished. So as you can see, my shape did get larger, and it didn't tell us to use a center, so actually all of my points moved, as opposed to the last problem where point S did not move. In this problem, all of my points moved because I used the origin as a center, so it's actually all the points are getting a little further away from the origin also. So as it's getting larger, it's getting further away. So you can imagine if it were getting smaller, it would actually get closer to the origin also. So for example 3, in the figure, segment X prime, Y prime is a dilation of segment XY. So it says find the scale factor of the dilation and classify it as an enlargement or as a reduction. So, well, just looking at this, we have the original is XY, and X prime, Y prime is the dilation. So which one is larger? Well, the original was larger, so we know that this is a reduction already. Oops. We know that this is going to be a reduction problem, so we know that my scale factor is going to be less than 1. So let's count and see how far we are for the original. We're at 1, 2, 3, 4. That's -4. And we're up 2 to that point. And for Y, we're at 1, 2 positive, and 1, 2, 3, 4, 5, 6 positive. And then for X prime, we're at -2, 1. And for Y prime, we're at 1, positive 3. So what we want to do here is we want to take our dilated values and put them over our original values to see, what our ratio is going to be. So we have -2 and we have -4. Again, this is my X from this one and my X from this one. And we know that that's going to be equal to this value 1 over this value 2. And actually, it just so happens that it was our simplest form of that as well. So our negatives here will cancel, and we can simplify 2/4 to be 1/2. And a negative over a negative is 1/2. And if we look at the other side, we can do the same thing. We're going to put our 1 on top because that's our dilated image. So 1 over 2, and then also 3 over 6. And we see across the board, our scale factor is 1/2. And that does make sense for us because we knew it was going to be a reduction, so it should have been smaller than 1. If we would have accidentally put these numbers on top, and we would have gotten 2 over 1, and so we would have been thinking, well, the scale factor looks like it's 2. Well, we have to stop and think, does that make sense? Well, the image of the shape is getting smaller, so having a scale factor larger than 1 does not make sense. So that should make you throw up a red flag and really think about that. And always put your new image, always put those values on top to find your scale factor. Our last example, the pupil of Josh's eye is 6 millimeters in diameter. So here we are actually talking about an eye problem. His doctor uses medicine to dilate his pupils by a factor of 3/2. So by seeing that right away, we know that the pupil is going to be getting larger because that's a number greater than 1. It says find the new diameter once its pupils are dilated. Well, again, factor means we're multiplying. So we're just going to take 6 times the scale factor, 3/2. Well, 6 can be written as 6 over 1 times 3 over 2. And we can simplify before we multiply to get this down to 3 over 1 and 3 over 1. And so we're just going to get 9 millimeters. And that is the diameter of his pupil. So that would be how to show the work there and how to answer that problem. Again, factor means we're multiplying, and then it gives you what to multiply by. So that's going to be our last example for today's lesson. Please check out the online tutors if you have any more questions.